The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, today we're going to take a look at section 11.1. We're going to start the last chapter that we're going to be covering this quarter, chapter 11. And so let's take a look at some things. Let's say I had a function, f of x equals 2x plus 5. And I wanted to evaluate that function at 3. So I'd say f of 3 is 2 times 3 plus 5, which is 6 plus 5, which is 11. And if I wanted to evaluate it at -4, I'd have 2 times -4 plus 5, which is -8 plus 5, which is -3. So far, so good? Okay, what if I wanted to evaluate f of 4x minus 7? Whoa, that means I'm going to take all of that and put it in the place of x. So I'm going to have 2 times the quantity, 4x minus 7, and then plus 5, which would be 8x minus 14 plus 5, or 8x minus 9. Any questions about what I just did? Okay. What if I had f of x equals 2x plus 5 and g of x equals 4x minus 7. And I wanted to evaluate f of g of x. So I'm going to evaluate f at g. Well, g of x is 4x minus 7. So this would be equal to f of 4x minus 7, which would be equal to 2 times the quantity 4x minus 7 plus 5, which would be equal to 8x minus 14 plus 5, which is 8x minus 9, which is basically the same thing I did right here, only I gave 4x minus 7 a name and called it g of x. We okay so far? All right. We're going to look at an operation today called composition. The symbol for composition looks like a little circle. So let's say we had f of x equals 2x, what was it, plus 5, and g of x equals 4x minus 7. If we wanted to take f composed with g of x, so that looks like fog, maybe it'll feel like fog, but so this is f composed with g of x. What that means is we want to evaluate f of g of x. So f composed with g of x means f of g of x, okay? Which would be f of 4x minus 7, which would be 2 times 4x minus 7 plus 5, which is 8x minus 14 plus 5, which is 8x minus 9. And yes, I keep doing the same problem over and over, but this is where I wanted to get to. F composed with g of x. Okay, so we're evaluating f at g. Now, let's take those same two functions, f of x equals 2x plus 5 and g of x equals 4x minus 7. All right, okay. And let's find g composed with f of x. So that means I want to find g of f of x. Well, f of x is 2x plus 5, so g of f of x is g of 2x plus 5, which would be 4 times the quantity 2x plus 5 minus 7, or 8x plus 20 minus 7, or 8x plus 13. So notice f composed with g of x is not equal to g composed with f of x. So composition in general is not commutative. There are some cases where it is commutative. We'll be looking at those tomorrow. But in general, the operation called composition is not commutative. All right. Any questions so far before we go on? Okay, let's take a look at some examples. Some more examples, rather. Let's say that f of x equals 2x plus 1 and g of x equals x squared minus 1. They want us to find f composed with g of 2. So now we're looking at a specific value. Well, f composed with g of 2 is equal to f of g of 2. But what is g of 2? Well, g of 2 would be 2 squared minus 1, 4 minus 1, 3. So this, there we go. This goes in the place of that. So f of g of 2 is equal to f of 3, which is equal to 2 times 3 plus 1, or 6 plus 1, or 7. So f composed with g of 2 equals 7. What we're doing isn't complicated, but you've got to do things in the right order. So you got to get used to the way things work, but the actual calculations shouldn't be anything that's new. All right. Using the same two functions, f of x equals 2x plus 1 and g of x equals x squared minus 1. Let's find g composed with f of negative 3. So g composed with f of negative 3 is g of f of negative 3. What is f of negative 3? Well, that's 2 times negative 3 plus 1, because we're putting it in there, which is negative 6 plus 1, which is negative 5. So negative 5 goes in the place of f of negative 3, and we get g of negative 5, which is equal to negative 5, the quantity squared minus 1, 25 minus 1, 24. So g composed with f of negative 3 is 24. Again, any questions? All right. One of you asked for a couple of questions from some homework, and I'm going to go ahead and do those as examples now that I think we're ready. This is from section 11.1, number 8. And it says this. It says, let f of x equal 5x plus 4 and g of x equal x squared minus 8. It says find the following: g composed with f of 4x. So that's equal to g of f of 4x. So we need to start on the inside and find f of 4x. Well, f of 4x would be 5 times, but then all of this goes in the place of x there. So 5 times 4x plus 4, which is 20x plus 4. So then this goes in the place of that, and we get g of 20x plus 4. We're not done. And that goes in here, So we get 20x plus 4, the quantity squared, minus 8, which is 20x plus 4 times 20x plus 4 minus 8, which is 400x squared plus 80x plus 80x plus 16 minus 8, which is 400x squared plus 160x plus 8. Any questions about that example? So again, each calculation isn't difficult, but you got to do the right things in the right order. Still good? Okay. This is another one. This is number 16. Okay, here. It says, let f of x equal 8x minus 4 and g of x equal x squared plus x. Find the following: g composed with f of x. Well, g composed with f of x is g of f of x. But f of x is that, so that goes in place of that, gives us g of 8x minus 4, which now that goes in there. So we have 8x minus 4, the quantity squared, plus 8x minus 4, because it's x squared plus x. So that's 8x minus 4 times 8x minus 4 plus 8x minus 4. I can drop the parentheses because it's plus in front, which is 64x squared minus 32x minus 32x plus 16 plus 8x minus 4, which is 64x squared, minus 64x plus 8x would be what? Plus 56, not plus, minus rather, minus 56x plus 12. Sorry, didn't see that, 16. So plus 12. Any questions on that one? Okay, anyway, that was for a request from a student. Now we'll go back to some just more examples in the book. How about this one? Let's go back to f of x equals 2x plus 1. G of x equals x squared minus 1. Let's find f composed with g of 1/2. So that would be f of g of 1/2, which would be f of, well, let's see, g of 1/2 is 1/2 the quantity squared minus 1. 1/2 times 1/2 is 1/4 minus 1, which is 1/4 minus 4/4, which is negative 3/4. So that's going to go in here. Still with me? And that's going to be 2 times negative 3/4 plus 1, which is, let's see, that reduces down, negative 3/2 plus 1, negative 3/2 plus 2/2 equals negative 1/2. So f composed with g of 1/2 equals negative 1/2. Any questions on that example? Okay, let's see here. Suppose f of x equals 3x minus 2 and g of x equals x squared plus x. Let's find f composed with g of 4. So that's equal to f of g of 4. G of 4 is 4 squared plus 4, which is 16, plus 4, which is 20. So G of 4 is 20. So 20 goes in the place of G of 4. So now f of 20 is 3 times 20 minus 2, 60 minus 2, 58. So f composed with G of 4 is 58. Am I going too fast? Is anybody even there?
No, I'm going along with you.
Okay, all right. Thought maybe you all, headed off to lunch or something. Okay. Let's do another one. Let's again say that f of x equals 3x minus 2 and g of x equals x squared plus x. Let's find g composed with f of negative 3. Well, that's equal to g of f of negative 3. Well, f of negative 3, which is going to be there, is 3 times negative 3 minus 2, negative 9 minus 2, negative 11. So that's going to go in there. So g of f of negative 3 is g of negative 11, which is negative 11 squared plus negative 11, which is 121 plus negative 11, which is 110. So g composed with f of negative 3 equals 110. All righty. Suppose, whoops, I keep getting the wrong colors here. Suppose f of x is 1 over x and g of x is 1 over x squared. Let's find g composed with f of 1/3. So that's equal to g of f of 1/3. Well, f of 1/3 is 1 over 1/3, which is 1 divided by 1/3, which is 1 times 3 over 1, which is 3. So that goes in there. So now I've got g of f of 1/3 is g of 3. Sorry, that buzz is somebody's calling me and my phone's off, as it shall remain off. So that's g of 3, which is 1 over 3 squared, which is 1/9. So g composed with f of 1/3 equals 1/9. All right. Here's another one. Again, let's say f of x equals 1 over x and g of x equals 1 over x squared. Let's find g composed with f of 8x. So that's g of f of 8x. Well, let's see. F of 8x, that's going to go here, is 1 over 8x. So then that's going to go in place of that. So that's equal to g of 1 over 8x, which is 1 over 8x squared, which is 1 over 64x squared. You still with me? How I got from here to there, which is 1 divided by 1 over 64x squared, which is 1 times 64x squared over 1, which is 64x squared. So g composed with f of 8x equals 64x squared. So it's mostly just algebraic manipulation. Okay. Now, let h of t equal the square root of t plus 3 and k of t equal t minus 5. Find h composed with k of 18. So h composed with k of 18 equals h of k of 18. Well, k of 18 is 18 minus 5, which is 13. So 13 goes in the place of k of 18. So now we have h of 13, which is the square root of 13 plus 3, which is the square root of 16, which is 4. So h composed with k of 18 equals 4. Questions there? All right. Again, let's say let h of t equal the square root of t plus 3 and k of t equal t minus 5. And let's find k composed with h of 22. So k composed with h of 22 equals k of h of 22, okay? H of 22 is the square root of 22 plus 3, which is the square root of 25, which is 5. So that's going to go in the place of h of 22. So now I've got k of 5, which is 5 minus 5, which is 0. So k composed with h of 22 equals 0. Any questions there? All right, I talked earlier about how composition in general is not commutative. And so here we're going to just do another example of that. It says if f of x equals x plus 1 and g of x equals 2x minus 5, show that f composed with g of x does not equal g composed with f of x. So again, compose them in both directions and show that we don't get the same answer. All right. So first of all, let's take a look at f composed with g of x. Wait a second here. Down the page. That's equal to f of g of x. And that's equal to f of, well, g of x is 2x minus 5. So f of 2x minus 5, which would be 2x minus 5 plus 1, or 2x minus 4. So this equals that. Any questions on that part? Okay, so now let's do g composed with f of x. G composed with f of x equals g of f of x equals g of x is what? F of x is x plus 1. And then g of that would be 2 times the quantity x plus 1 minus 5, which is 2x plus 2 minus 5, which is 2x minus 3. So that equals that, and those are not equal. Close, but what do they say? Close only counts in horseshoes and hand grenades. Yeah. All right, so composition of functions. Get used to the notation. I will be back this afternoon at 1:15 with an office hour. Otherwise, I will see you tomorrow at 11:30. I'm going to go ahead and stop the recording.